Good afternoon, all. First of all, I would like to say greetings from the ISSMGE President Leslie Laloi, who has taken charge. And on June 14th, the new team has taken charge in Vienna during the 21st ISSMGE. I would like to start with the thanks to Marwan for the support in electing me as the Vice President of Asia and all the dynamic role he is playing to bring the importance of geotechnical engineering in this entire area. Thank you, Marwan, for that. Let's give a big round of applause to Marwan to start with. Today, I present to you a couple of case studies on deep excavation and the understanding of the soil behavior during the demolition of high-rise structures. So these are the two case studies which I would like to share, both case studies from India. And this is the area which I will be covering the topic today. A brief profile of myself. Now, rapid urbanization and emerging challenges is happening across, and we have seen that the multi-level basement structures, underground transportation system, utility corridors, and redevelopment of existing city plays a vital role, and limited availability of land is a big challenge which is happening. And working in densely developed environment, urban excavation and demolition projects needs a lot of attention and lot of instrumentation and monitoring, which was discussing today during the soil structure interaction panel discussion, a very, very important aspect which they have covered there. So existing safety and asset protection, effective risk management, and comprehensive monitoring are the three vital steps which we have to carry out. I take up about two case studies. One is the forensic study of a touch pile system failure of commercial building in Cochin. And second is the behavior of soil during the demolition of a multi-rise building and how the prediction was done and how the behaviors were established by using instrumentation. So this is where I come from, the beautiful city of Kochi, also known as the Queen of the Arabian Sea, a small area down south of India. And this project is 3 basement plus ground and 8 floors. So they had parking at 4 levels and a commercial space. And we had a touch pile system comprising of 337 piles of 90 centimeter diameter, going up to a depth of 30 meter and 28 soldier piles to have a strutting system in order to economize the design of the retaining wall system. And the building piles were taken to 43 to 46 meter, and they have to go for a depth of excavation up to 10 meter. So this was the condition. So the work was done in 3 phases. During phase 1, excavation was carried up to 2 meter after the touch piles were done, and strutting work supported on soldier pile was provided. And phase 2, the excavation was carried up to 6.5 meter, and in the third case, the excavation was taken up to 9.5 meter from where the foundation has to start. So let's see this video. So this is what was happening on the previous evening when the work was going on. And it was just the monsoon is about to arrive and they wanted to speed up. And let's see what exactly happened about 1 hour after this incident.
Shut up.
So this was happened at 4 o'clock. There was a slight movement of the wall. The water pressure started building up, and they reported to the district disaster management authority, and I was in charge as the engineer in head. I visited the site, and to my shock, there were 40 people working down trying to stabilize. And the first step was to evacuate. We evacuated, and in 10 minutes, what we saw in the second video happened. The entire thing collapsed. Now we wanted to find out what is the root cause of the failure and understand that why it happened and what is the reason and how to proceed further was the purpose of the study. So this is happened on 19th of April 2018, and this was the condition the next day morning. So the entire thing collapsed. So the metro had to come to a halt because the half of the road was in the property, all the drainage, everything went down, and that building, that red color building, its foundation was exposed and is slightly tilting into the other area. So this is the situation. You can see that all the machineries are buried down below. And this is the problems which was happened. And all those problems discussed. And a committee was formed to study what is the reason for the collapse of touch pile system, verification of government approvals, and suitability of touch pile system for further construction. So this was the initial step taken. We rerouted the public traffic, refilled the area, 2-layer sheet piles were provided, and all the testings were carried out, core test, integrity test, to understand where the failure was happened, and it was modeled in Plaxis as well as CAD to understand how the behavior was happening. So here you can see the withdrawal of the pile, 90 centimeter pile, you can see that how it has happened. We have refilled the area to control the lateral thrust. So this is how it was happening. So this is the double layer sheet piles which is provided, and drainage being provided to ensure that the water is released, and concrete core tests were carried out. We found that the concrete is of good quality. Pile integrity test, we found that the depth of failure was moved, even though there was only 10 meter, due to the liquefaction process, the unsupported length has become 15 meter, and the collapse due to the jump of moments has happened because of that. Additional soil investigation was also carried out, and Plaxis and STAT software is used. So this is the testing being carried out, and this is the core samples retrieved. Integrity test, this is what I showed. The point of fixity has moved down to 14.5 to 15.5 meter, and the 30 meter pile failed. These are the results of the integrity test which is carried out, and here you can see that the sudden change in behavior which is happening leading to the collapse. And this is the soil profile. A very weak subsoil profile was the major root of problem. And now we have to get into the drawing board, study what exactly went wrong, and stage analysis was carried out. So this is the basic equations where we started working on, and we worked out what is the capacity of the pile to withstand. You can see that it has a capacity of 815 kilometer. So we did stage analysis, what will happen at 5 meter, 6 meter, 7.5 meter, 9.5 meter. And then, so 5 meter everything is safe, 6 meter factor of safety is still 1.3, 7.5 it was brim, deflection and overturning moments were high, and bracing has to start into action. And this is the bracing system which they adopted. We stimulated it in the model, and we worked out the utility ratio, and at 9.5 meter there is a sudden jump of the movement, and the pile is not capable to withstand once the bracing system fails. So this is the 3-dimensional model of the system generated to study the behavior. And after the in-depth analysis, we found that inadequate strut system, soft soil, yielding of soil, high thrust from shoring pile, increase in unsupported length of pile has led to the failure. A second tier of strut system, if provided, would have avoided the failure. So this was the final conclusion. And it was sheer luck that there was no human casualty happened during the incident. And work was carried out by providing additional piles, additional supporting system. We asked them to give more setback from the road. Instrumentation was carried out extensively, and the work is completed, and the building is operational now. So this is one case study, because whatever is in theory, it doesn't work in the field. You have to monitor properly and take action as and when things happen. So that's a very important aspect when we are getting into the design of that. And my second story is that of a demolition, and demolition of a high-rise structure by delayed detonation technique. So we put explosives in different part of the building. We go there. So if I am taking the theory, it is very simple. Step 1, survey the surrounding area, study the building plan, study, remove toxic substance like asbestos, flammable material, etc. Remove non-load bearing wall. Why? Because I want to have less impact of load hitting the ground. So remove the non-load bearing wall, drill holes in columns, put your explosive, move away, press the button, building comes down. Very easy in theory. But when you do it practical, there are so many butterflies in your stomach. You are not sure whether you have to press it or not when the time has come. So let's see this video.
Good evening. The implosion dominates tonight's special edition of 10 Capital News.
We begin with the disastrous aftermath of yesterday's implosion. It's estimated a crowd of 100,000 people lined Lake Burley-Griffin to witness history. What followed will be etched in the memories of us all for years to come.
Organisers had intended yesterday's demolition to be spectacular, They couldn't have imagined the traumatic effects it would have on the national capital. Instead of a safe, fully contained implosion, boats on the lake and crowds on the other shore were showered with debris, shards of steel warped and twisted by the force of the blast. The 12-year-old girl was hit and instantly killed, 9 others taken to hospital with minor injuries. Even today, no one could tell why the implosion turned into an explosion.
It'll be a painstaking and detailed investigation by the police. It's largely a matter, as you'd appreciate, I guess, of structural engineering questions, questions of physics, to determine the cause of the fatality and the injuries that were occasioned.
The girl was killed 480 metres from the demolition site, nearly 10 times the prescribed safe distance set down by contractors. But today, witnesses
So previous case we saw that the implosion was huge. So the collapse was, it found that the girl died, so many casualties happened. And second case, they put less explosive. And always when we work on this project, our team lead is from South Africa. He always keep telling, if you don't do good engineering, the building will stand there and laugh at you. So that is what we saw, the building standing there and laughing at the engineers who did the job. Okay, so now I'm coming to my story. This is the second largest demolition in the world. The first one happened in Abu Dhabi, the Mina Tower, that is the tallest. So this we did for Supertech Twin Tower Noida. A 7 lakh square feet building of, in Noida was brought down for violating the rules. And this was done. And this is the building. You can see that the building is surrounded by structures all around. And the building is 107 meter tall, and it has to be brought down without affecting that. And to add more worry to the problem, this is the building which is standing tall and about 60,000 tons. This is the history. And to add more problem to that, we have a live Gale gas pipeline which is running just 23 meters away from the structure, and we cannot stop that. And we have to do it, and you get only one chance to do the job. You don't have a second trial. So this has to be done, and the building has to be brought down, and everything has to be measured. So because there will be a lot of court cases happening after that. So everywhere we had instruments placed. The team worked hard. So this is surrounded by Emerald Court and ATS Village. Initially, the building, which is a tall story, is just 9 meters away, and we have to get the demolition done without happening. This is the world's largest demolition happened, that is Union Carbide, but it was by mechanical demolition. And implosion technology, this is the second world's largest demolition. And to do this job of building 500 crores worth of asset, the time took us was just 9 seconds. But for that 9 seconds, we did 6 months engineering. 6 months of detailed engineering. I am based out of Cochin in Kerala. I have to fly 3 hours to reach Delhi. So I used to go there once in a month previously. Then it was twice a month. Then I was there camping in Delhi. And the last 3 weeks I was in the site to make sure that everything is going on. If you look at the lines, these are the seconds which I need for the implosion to happen. And the building will come down automatically. And we have to, these are the primary and the secondary blast floors. So this is the 9 seconds operation which was done. And to make sure, the court has instructed that none of the building should be damaged because of this. So there was a team mentioning. So we monitored, made video records of all the building, did a lot of NDT testing, proved what was the strength there, and everything was documented and submitted to the Supreme Court of Law. And rapid visual instrument assessment was carried out, and all these buildings were recorded. Even slight negligible cracks was also reported. And these are the ND tests being carried out, and everything was modeled using the softwares. Due to scarcity of time, I am not going through. I am here. Anyone has a doubt, you can come to me. We can discuss. This is the ETAPS modeling, stimulating, and this is the behavior which is happening. What will happen when the impact happen? What will happen when an earthquake come and hit during the process? What will happen when the blast load come and hit? It is stimulated in the structure, and you can see how the behavior is happening during the impact. This is for earthquake, and this is for the blasting load. So once the blast hit the ground, building will start moving, and everything is proved and submitted to the court of law that as per design, everything is perfect. Then the D-Day came. You have to get the button pressed. So this was on if I can control, the technology of delayed determination is very simple. If I can control my vibration to 3.5 centimeter per second, there is not going to be any damage. If it is more than 11 centimeter per second vibration, there will be huge damage in the surrounding built environment. So thanks to the team from IIT who are working along with me on this project. So these were the points where we recorded. This is the IIT team who helped us putting geophones, vibrometers, accelerometers, so much of instrumentation, including thermal images, photographs, and like we do in this thing, we have all sensors connected to the structure to understand what exactly was the behavior happening. And this is the Gale gas pipeline, which was monitored live. So you can see the video, how the behavior happens, how the vibration is controlled. So every time less than 1,000 tons hit the ground, so that we don't allow it to peak up. So this is the values, everything was under control, luckily, and this was on date 28th of August, 2:30 p.m. We have to go for the blast, and this is what exactly happened. So the building has become a history. It is no longer there. So we have done the recycling of the debris and the aggregates, and was used for road works. And current takeaway, urban construction activities require proactive geotechnical risk management, particularly when deep excavation and demolition are undertaken near existing infrastructure. Deep excavation failures are often the result of combined factors, including inadequate temporary support capacity, insufficient understanding of subsurface condition, and neglect of soil structure interaction effects, which was very much discussed today. Forensic investigation provides critical learning opportunities by identifying root causes of failure and improving further design and construction practice. Protection of critical infrastructure during demolition demands meticulous planning. Instrumentation and real-time monitoring are indispensable tools. An integrated approach involving design, execution, monitoring, and review significantly enhances construction safety and resilience in urban environment. Some photos. These were the team from IIT who was supporting us on the job. This is Joe Brickman, the team lead from South Africa. So we were just before the blast. This was the last photo taken, and the girl is my daughter, who is currently an earthquake structural engineering from University of California, Los Angeles. So this was the last photo taken before we went for the blast. And Akshay Kumar playing the role of the demolition engineer. And let's see this video in Malayalam. This is from Mohanlal from Malayalam movies.
ചിലപ്പോൾ പണിയും ചിലപ്പോൾ പൊളിക്കും.
The only place where success comes before work is in dictionary. Let us all work together and success will follow. Thank you all for a patient listening.